Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera to dear panels and supervisor. My name is Izzat Amir bin Ahmad Nizamuddin and I will presenting my FYP proposal with the title of Power System and Mechanics of Hybrid Generator. In this proposal presentation, I will talk about the project summary, the introduction or background of the project, the literature review based on the findings related to the project, the problem statement and objectives, the scope and limitation of the project, the methodology which consists of design concept and sample calculation, and finally the expected results of the project. Now, let's begin with the project summary. This research is about a hybrid generator system used to generate electricity by converting magnetic induction force into mechanical energy, which is then converted into electrical energy by the generator. Focusing on the new renewable energy using magnetism, creating a prototype of the hybrid generator entails simulating a combination of magnet solenoid to demonstrate how the system reacts when the magnetic flux from the solenoid exists. To generate power, this prototype will employ translation motion, which is then converted into rotational motion. Using computational aided design simulation, Katia assisting in the results and findings of the research which will consist of improving the speed and optimizing the power output and the study of dynamic concept of power transmission by using gearing and gearbox system. Now, let's proceed to the introduction and background of the project. The rising need for energy caused by population expansion as well as the advancement of science and technology has aided various developments of renewable energy. Numerous studies have been conducted to predict the lack of energy sources, beginning with the use of energy produced by natural resources, including water, wind, geothermal, and solar energy. As an alternative to the existing renewable energy, the hybrid generator system was created to assist those who live off the grid and those who reside in areas without access to energy, such as indigenous people or parties who are trying to conserve energy usage. Moreover, the development of the hybrid generator as a new backup energy sources, diesel energy generator which use diesel and bring numbers of impact towards the environment will be possible to be replaced. Furthermore, the hybrid generator has no environmental impact and produces no carbon emissions. The studies will focusing on maximizing the output of the existing hybrid generator using magnetism concept to electrical energy by improving the mechanical aspect of the generator by combining several numbers of engineering design knowledge, theories and laws related to Lenz's law, Faraday law, solenoid, magnetic induction EMF and mechanical design. The mechanism of the hybrid generator will first produce a linear movement from the solenoid, and magnetic induction will then be transferred to a translational motion towards rotational motion. Focusing on various aspects of problems from the existing hybrid generator, the target of the study will also include the sufficiency of energy supplies for the output, the compatibility of the generator and accessibility of maintenance over a long period of time. The parameters that will be considered in the rotation is the rotation speed of the shaft, revolution per minute of generator, transmitted power and torque value of the shaft. Figure here shows the existing design of the hybrid generator based on the previous studies. Now I will elaborate some of the main points based on the literature review from numbers of articles or journals that I have summarized. The literature review is divided into 4 sections. I will start with the renewable energy in Malaysia. Renewable energy is growing rapidly and becoming a popular alternative source of energy. Malaysia is looking forward to achieve 50% implementation of renewable energy by 2050. Environmental problems have been linked to sustainable energy development, which can be solved by switching from fossil fuel to renewable energy sources, including hydropower, solar, and wind. In order to protect the environment and natural resources for an extended period of time, Malaysia's Ministry of Energy, Green Technology and Water (MEGTW) is stepping up its effort in the areas of RE and energy efficiency. As a result, consistent efforts must be made to implement green technology so that people can alter their lifestyle to support a sustainable environment. Thus, with the implementation of a hybrid generator, it enhances the capabilities of electrical supplies regardless of any Malaysian population, be it in the rural area or urban area, which will definitely bring a better impact towards the energy consumption in the nation. So for the next literature review is the Faraday's law, Lenz's law, and magnetic induction. It is stated that the direction of the current produced in a conductor by a changing magnetic field is such that the magnetic field generates opposes the initial changing magnetic field that give rise to it. As shown in the figure below, creating a wire loop and attaching the end to a galvanometer or sensitive current meter. After that, if you pass a bar magnet through the loop, the galvanometer needles will move, signifying an induced current. But as soon as the magnet stops moving, the current equals zero again. Only when the current is growing or dropping can the magnetic field cause one. A new current will be induced in the wire if you remove the magnet, but this time it will flow in opposite direction. This concept was similar concept that will be used on the hybrid generator, and by using the equation below as the theoretical proof that this project is possible to be conducted. Next section of literature review is solenoid electromagnetic engine. As found in the article and journals, the electromagnetic engine features all the same parts as a typical internal combustion engine, including piston rings, cylinders, connecting rods, and shafts. The cylinder head and piston head of this engine each have a permanent magnet and a solenoid attached to them. When electricity is applied to the solenoid, it behaves exactly like a typical magnet. The connecting rod and crankshaft of this engine translate the attraction and repulsion properties of magnetism into reciprocating motion, which is then converted into mechanical work. This engine would do well to operate in the same way as a typical internal combustion engine. By combining the magnetic induction theory, it is possible to create a solenoid engine similar to the internal combustion engine with the right mechanical design implementation. And the last section is the power transmission and gearbox. Gearboxes are used to transfer power from a generator to a user or vice versa with considerably variable torque and speed characteristics. Power is impossible and cannot be transferred with a single gear alone. Bearings are used to stabilize shafts so that gears can transfer power steadily. Oil is used to reduce heat generation in the gear teeth, speed up gear meshing, and reduce gear abrasion. The proposal of using gearbox system on the hybrid generator will somehow increase the tendency of the output power for the hybrid generator to be maximized, while taking some factors such as vibration, gear noises, and gear failure for the continuous usage of the system. In general, gear trains need to be able to carry enough weight to function well in a particular application, such as to maximize the output of the hybrid generator using magnetism application. The problem statement of this project is by conducting a study comparing the existing old hybrid generator system to the new improvised hybrid generator system. The best parameter can be observed, such as the output power and the maximum time for the continuous usage of the hybrid generator. And the objectives of the project are to improve the output power of the hybrid generator using gearbox conceptual design and to increase the longevity of usage for a continuous run of the hybrid generator. For the scopes of the project, focusing on the designing and improvisation of the existing hybrid generator by using conceptual design in CAD software CATIA V5. The designing process of the gearbox of the generator consists of different parameters such as the diameter of the pinion shafts, number of gear teeth, and many more. The output power generation by the hybrid generator will, with the usage of the gearbox, needed to be investigated and compared. Next is the limitation of the project, which is the lack of studies or researchers for references for the improvement of the hybrid generator using gearbox system. Moreover, there might be a lack of analysis of the force acted on the gear surfaces that might cause vibration of or energy losses. Finally, the efficiency of the output power of the generator might not be accurate due to the difficulty to determine the type of energy losses that might occur using different types of gearbox. Now proceeding to the methodology of the project, figure here shows the flowchart of conducting this research and studies. From the above, which is establishing the hybrid generator dynamics and mechanism, analyze the specification of the power system, develop CAD modeling, fabrication and assembly of the product, test and analysis, and finally compare the output of the product between two types of design. For the design concept, the figure we have here is the first design of the gearbox, which is the two-step gearbox. It is consists of 4 spur gears with different parameter and 6 bearing. Here shows the description and parameters of the two-step gear that was designed using CATIA. The first gear will be connected to the crankshaft and the fourth gear will be connected to the generator. Meanwhile, the second and the third gear are known as the idler gear, which is used to reduce torque and increase the power transmission. For the second design here is the two-stage gearbox, which consists of 2 helical gear and 2 spur gear with 6 connecting bearing. The variation of the gear type here is to estimate and compare the possible outcomes of the output power to the generator. This is the description of the second design, which is the two-stage gearbox where the first spur gears will be connected to the crankshaft while the last fourth helical gear will be connected to the generator. Here are the sample calculations that was taken in order to calculate the power that can be transmitted to the generator from the gearing mechanism by referring to the mechanical engineering design books that consists of ASTM rated table and following the equation and parameters obtained from the description of the gearbox. For the expected results of the project, where there are 2 types of design for the gearbox and 3 types of design for the hybrid generator that will be proposed. The result of the output will be determined after the fabrication using CATIA and 3D printer. The results will then be compared whether the goals are achieved for this project. The figure on the left here shows the two-step gearbox assembly with first improvised hybrid generator design. On the right side shows the two-stage gearbox assembly with the second improvised hybrid generator concept. And the last one here shows the third improvised hybrid generator concept without attaching it to the gearbox. Please take note that the gearbox system are made and designed to be universal and compatible regardless of however the design is for the improvised hybrid generator. This is the end of the proposal presentation. Thank you for your time and Assalamualaikum.